In today's lesson, we're going to have a look at sketching some circular functions or trigonometric functions with the horizontal translation, or in some cases, it's also called as phase shift. So we're going to look at a couple of examples in this scenario, right? In both the cases, we're going to take into account different domains to deal with, thereby presenting different complications to the question. All right, so let's start with the very first one. So we've been asked to sketch the graph of the following function for x between minus pi and pi. So what I'm going to first do is I'm just going to break down this question into different parts. So obviously, just looking at the equation, I can see that the amplitude of this particular function is equal to 2, right? The period of the function can be found by 2 pi divided by n. In this case, the value for n is 2. So 2 pi on 2 gives us a period of pi. That we've got a horizontal translation of minus pi on 4, so which means we're moving to the left by pi on 4 units. We also have a vertical translation of the square root 3. Right? Just with that piece of information, I'm also going to just note down a few other things to make it a little bit easier for me later on to sketch this function. Right? Now, so which tells me the vertical shift is square root 3, which means the mean value of this particular cost function is going to be square root 3. That's going to be where the center is going to be. So let's call that as the mean. Right? The maximum value is going to be the mean plus the amplitude, so which is going to be 2 plus the square root of 3. That's going to be the maximum, and then the minimum is going to be square root 3 minus 2, or we can also write it down as minus 2 plus square root 3. That's going to be the minimum value of this cost function. Now, like I always say, it's always good to roughly estimate these values, just to make it a little bit easier for us to sketch when we use a graphing page for this scenario. Right? So if I was to estimate the value of the maximum and minimum in this case, now square root 3 is roughly 1.73, right? Which means the maximum is roughly going to be 3.73, right? We've talked about square root 3 being 1.73, and 1.73 minus 2 roughly is going to be 0.27, right? Now this is going to make it a little bit easier for us to make the placement on the y-axis when we go into the sketching mode. All right, so just looking at the maximum and minimum, that tells me that this particular cost function is going to have some x-intercepts, because we've got some values above the x-axis. We also have some values below the x-axis. Just made a mistake here. It's actually minus 0.27. That's a maximum is 3.73. Our minimum is minus 0.27, which means the graph actually has x-intercepts, right? So that's what I'm going to do next. I'm going to work out the x-intercepts for the domain. So to find out any x-intercept, what we do is we start by making y 0. So let's start by doing that. So 0 equals 2 times cos 2 x plus pi on 4 plus the square root of 3. Right, now we're going to go ahead and make the cos as a subject of this equation. So I'm going to have cos 2 times x plus 4 equals minus square root 3 over 2. All right, now that we've worked out the value for cos as a minus, right, we can quickly revisit our 4 quadrants and quickly gauge where it's going to fall under. Right, cos is negative in quadrant number 2 and quadrants number 3. Right, we still have to go ahead and work out the value of theta in the first quadrant. Now, cos is equal to square root 3 on 2 for the value of theta being pi on 6. Right, so let's go ahead and solve this function. Right, so which means we're going to have 2 times the second quadrant and the third quadrant is where cos is negative. So we're going to have, right, 2 times x plus pi on 4. Now any angle in the second quadrant can be found by using pi minus theta, and the third quadrant is going to be pi plus theta. So pi minus pi on 6, right, which is nothing but 5 pi on 6, right? And similarly, we're going to also have 2 times x plus pi on 4 equals pi plus pi on 6, which is going to be equal to 7 pi on 6, right? We still need to solve for x in both the cases, so we're going to divide both sides by 2. Right, dividing both sides by 2, I'm going to have x plus pi on 4 equals 5 pi on 12. Right, and again, one last step in solving for x. We're going to subtract pi on 4 to both sides. So leaving us with 5 pi on 12 minus pi on 4, right, making the denominators the same. We're going to end up having 3 pi on 12 here, so that's going to leave us with 2 pi on 12, or in simplified version, it's just going to be pi on 6. So x equals pi on 6 is going to be one of the x-intercepts for this particular question. Right, now quickly getting the value for the second one. So again, dividing both sides by 2, right, plus pi on 4 equals 7 pi on 12, and x is going to be equal to 7 pi on 12 minus pi on 4, right? It's going to be equal to 4 pi on 12, or in a simplified version, it's just simply going to be pi over 3, right? And that gives me the value of the second x-intercept. Now, very quickly, I'm just going to go back to the question itself, right? We talked about the period of the function being equal to pi, and the domain of this question is from minus pi to pi, right? So that tells me that I could fit 2 cycles of this cost function in the domain. So what that could possibly mean to us in terms of the x-intercept is these are the x-intercepts in the positive direction of the x-axis, right? Which means we still need to find the x-intercepts in the negative direction of the x-axis, right? So what I'm going to do to find those x-intercepts, I'm simply going to subtract a period from each of the x-intercepts. So let's start by doing that. So the next x-intercept is going to be pi on 6 minus the period of this graph, which is equal to pi, right, which is giving me the next x-intercept as minus 5 pi on 6. Right, and then the last one, x is equal to pi on 3 minus the period, which is equal to pi, leaving us with the last x-intercept as minus 2 pi on 3. All right, beautiful. So we worked out the x-intercept, right? We also have to talk about the y-intercept as well as the endpoints for this particular function, right? So let's start with the y-intercept. So y-intercept is going to be, define the y-intercept, we make x equals 0. So if I make x equals 0, I'm going to have y equals 2 times cos 2 brackets 0 plus pi on 4. I believe it was plus square root 3, right? So that's going to give us 2 times cos pi on 2 plus the square root of 3. Now cos is, when we talk about the unit circle, cos is the x coordinate. So at 90 degrees, the x coordinate is 0, so which means 2 times 0, leaving us with a y-intercept of square root 3, right? So that becomes my y-intercept for this question, right? A couple other things, we're going to work out the endpoints. So we're going to work out the endpoints of this particular graph. Right, given the fact that we are starting at minus pi and finishing at pi, which tells me that no matter where I start, I'm going to be able to finish 2 complete cycles of the cost function. There's a good possibility that both the values are exactly the same, right? So I'm going to go ahead and find one of them, and I'm going to use that for the second value as well. So when f of pi, so which means we're substituting the value for x as pi. So we're going to get 2 times cos 2 brackets pi plus pi on 4 plus the square root of 3, right? Which is going to give us 2 times cos 2 brackets 5 pi on 4 plus the square root of 3, and again 2 times cos 5 pi on 2 plus the square root of 3, right? Cos 5 pi on 2. So 2 goes into 5 2 times, leaving with a remainder of 1. So which means it's basically going to be same as writing 2 times cos pi on 2, right, plus the square root of 3, and we've just talked about the value of cos pi on 2 being equal to 0, right? Therefore, this is also going to be the endpoint going to be equal to the square root of 3. So which means the value of the function when x is equal to pi is the square root of 3, right? So I'm just going to compile all of that in the very next page, right? So let's start by doing that. I'm just going to create some space. Right, so we have so far the endpoints as minus pi square root 3 and pi square root 3. Right, y-intercept of this particular graph is going to be 0 square root 3. Right, we've got 4 x-intercepts. Right, we like to write them in ascending order. So starting with minus, so which one's going to be first? Right, we're going to start with minus 5 pi on 6. Right, followed by minus 2 pi on 3. Then we're going to have pi on 6 and pi on 3. Right, those are my x-intercepts. Now, the next part is really critical, right? We've talked about the maximum and minimum, so I'm just going to write that down as well. So maximum is going to be 2 plus the square root of 3, right, approximately 3.73. The center value or the mean value is going to be square root of 3, approximately 1.73. And the minimum value is going to be minus 2 plus the square root of 3. We've talked about it being approximately equal to minus 0.27. Right, now we've compiled all the important piece of information. Let's quickly get into the graphing of this cost function. Right, let's start by marking the values on the y-axis here. We'll come to the x-axis in a minute. All right, so we're going to have, let's quickly do this, bear with me. Right, so we've got, I'm just marking my, right, y-axis, x-axis, right, and the 0 there. Right, so let's quickly mark these important values, right? So 1.73, right, and we've got a maximum of 3.73 and a minimum of 0.27, right? So I'm just going to go, I'm going to take one unit as one box as 1 unit, so which means 1.73 is roughly going to be there, right? 3.73 is roughly going to be there, and minus 0.27. I'm just going to drop off that 0 so we can make this a bit clearer. Right, it's really important that when you do it, you actually mark the 0 as well. Right, so minus 0.27 is roughly going to be there. Right. Now, one of the things we could do to make our jobs a little bit easier, right? This is a rough sketch, right? So we're going to basically, I'm just going to draw a line at each of the points, right? So just let me do that. These are going to be just like reference lines for our graphs. All right, that's the center and the minimum, right? This is a really good way to do your graphs really well. Obviously, just make sure at the end of it, make sure you can rub it off. So preferably use a pencil if you want. Now let's focus on the x-axis, right? The x-axis is really, really critical in this particular section, right? Now, if I look at the values that I have to plot on the x-axis, right? Let's start with our x-intercept. I've got minus 5 pi on 6, right? I've got minus 2 pi on 3. Right, obviously they're all with the different denominators, right? So the best way to deal with it is we're going to space it out in such a way that we're going to take into account the lowest common multiple for all the denominators, right? So the lowest common multiple for 3 and 6 obviously is 6, right? So which means we're going to try and space out the x values with the spacing of pi on 6, right? So let's start by doing that. So we're going to go from minus pi to pi. So 1, 2, 3, so that's halfway. 1, 2, 3, that's 1 pi, right? So I've spaced out 6 boxes for a distance of pi units on the right hand side. Similarly, 1, 2, 3, and 1, 2, 3, that's going to get me to minus pi, right? So these are the values we are going to plot between in terms of the domain of this particular graph. Right, now the next bit what we're going to do is we're talking about a cost function, right? Now this is something you can do first before you actually plot the original graph, right? So what I'm going to do first is I'm actually going to draw this graph without a without a horizontal translation. So which means we're not going to worry about the the horizontal translation of pi on 4, I believe. Yes, on pi on 4 to the left. All right, so we're going to draw this without the horizontal translation, which means we're just going to consider the graph equation as 2 times cos 2x plus the square root of 3. Right, so if I was to sketch this particular graph, right, I'm just going to plot some points on my graph there. It's a positive cos, which means we're going to start from the maximum. Right, we always like to sketch our sine and cos graphs in quarters. Right, so we're going to start with the first point being the maximum. Right, the first quarter is going to be, so obviously we've got 6 boxes to finish a period, right, and halfway is going to be at pi on 2, so which means that's where my minimum is going to be, right, which means the other 2 points are there. Right, so if I quickly join that with the graph, so I've got, right, similarly on the other side, that's where the minimum is going to be. No, that's where the period's going to finish. Right, 4 quarters, 1 quarter, second quarter, third, and then the fourth quarter. Right. So what we have done now is we've actually sketched the graph without a horizontal translation. Right. Now we're going to go ahead and sketch our actual function. Right. And let's mark some important points. All right. So I'm going to use the black pen to make these markings. Right. So let's start with the endpoint. So minus pi square root 3, right? So which means minus pi square root 3 is going to be there because that's the mean value. Remember when we talked about the mean value? Right, at the end point also pi square root 3, so that's where the second endpoint is. The y-intercept is 0 square root 3, so which is right on that point there. Right, so we marked those values there. Now let's talk about our x-intercepts, right? So x-intercepts are going to be marked here. Right, now before I get to the x-intercepts, right, let's talk about the horizontal shift. Horizontal shift is pi on 4 units to the left, right? So pi on 4 units to the left, which means now that point there is equal to pi on 2. So pi on 4 units is going to be exactly halfway. So which means everything is going to move to the left by pi on 4 units, which means the maximum point which I had at 0 is going to move to the left by pi on 4 units, right? So that's where it's going to start, right? And then everything else is going to follow its path, right? So obviously this point here is going to move to the left to the y-intercept. All right, now let's mark our x-intercept. So we got pi on 6. So remember we talked about one boxing being equal to pi on 6. So that's going to be my first x-intercept. Right, next one's pi on 3. Pi on 3 is same as writing 2 pi on 6. So which means this pi on 3 is going to be right there. Right, so that's going to be pi on 3, and so pi on 6, my bad. And this one's going to be pi on 3, right? And the other two x-intercepts going to be minus 5 pi on 6, so minus 5 pi on 6 is going to be there, right? 5 boxes to the left. And minus 2 pi on 3 is same as writing minus 4 pi on 6, so which means that value is going to be right there, minus 4 pi on 6, all right? So now, let's go back to the original graph, right? So obviously we've talked about 4 quarters, right? So we started at the maximum, right? Then the middle value is roughly 1.5 boxes there, right? And then the minimum is another 1.5 boxes away, 1.5 boxes again, and then finishing off with 1.5 boxes to the maximum, right? We're going to follow the same with our actual graph with the horizontal shift. So if that's where we're starting, right? So if that's where we're starting, 1.5 boxes, so that's in the middle, right? So we have this point here and the 0, so I'm going to connect that, right? The next value is going to be 1.5 boxes away, so just that point there. Make sure it's passing through your x-intercept, right? Then we're going to have 1.5 boxes again, 1.5 boxes. As you can see, we can nicely form our course graph there, right? And then let's finish off the other side too. Just bear with me. Right, 1.5 boxes to the next quarter. Right, similarly 1.5 boxes to the next quarter. Right, so if I join that, right, we just have to make sure it's passing through our x-intercepts. Right, And with that, what we've done is we basically completed the graph with the horizontal shift. So the black graph is going to be equal to the y equals 2 times cos 2 brackets x plus pi on 4 plus the square root of 3. All right. So I'm just going to emphasize this one particular thing. I'm just going to zoom it in a little bit so we can all see it really clearly. Right. Now, let's talk about the one without the horizontal shift, right? So we've talked about it. So what I meant by 1.5 boxes is each quarter there, as you can see, is about 1.5 boxes on the x-axis scale, right? So that's what we followed right through the graph with the horizontal shift, just making it a little bit easier for us to draw the function of the cos function with the horizontal shift of minus pi on 4, right? Um, we'll come to the conclusion of this video. I'm going to discuss another example in a follow-up video, so keep watching, and other than that, have a lovely day, and thanks for watching.